Voyager 2 has traveled farther than almost any machine humanity has ever built, crossing the boundaries of our solar system and venturing into a realm where the sun's influence begins to fade. Launched in 1977, it was never expected to survive this long, let alone continue sending back data from the edges of interstellar space. And yet, decades later, Voyager 2 still speaks to us, whispering secrets from regions no human has ever seen. But recently, what it transmitted back was not just another stream of ordinary measurements. It was something strange, something moving, something that is not a planet, not a star, and not anything we've clearly identified before. To understand why this is so significant, we have to remember where Voyager 2 is. Right now, it's more than 12 billion miles away from Earth, beyond the heliopause, the invisible bubble that marks the boundary where the solar wind from our sun collides with the interstellar medium. Out here, the spacecraft is no longer under the dominance of our sun's protective shield. Instead, it drifts in a sea of cosmic particles, magnetic fields, and interstellar phenomena that we have only been able to model in theory. In this lonely expanse, planets are absent. Stars are far away. The chance of stumbling upon something in motion is astonishingly rare. And yet, Voyager 2 recorded just that. The first clue came in the form of subtle anomalies in the data stream. Instruments designed to measure plasma densities, magnetic field shifts, and cosmic ray particles began to register disturbances that didn't match expectations. Voyager 2 had crossed into interstellar space years ago, so the environment should have been relatively consistent: low-density plasma, occasional cosmic rays, and faint interstellar magnetic fields. But then came something unusual, a repeated pattern of changes, almost like ripples passing across the spacecraft's sensors. These weren't random fluctuations. They suggested movement, something drifting, shifting, or flowing in a way that defied easy explanation. At first, scientists thought it might be a fault in the spacecraft itself. After all, Voyager 2 is more than 4 decades old, running on a nuclear power source that's slowly weakening. Its instruments, though remarkable for their time, are far less sophisticated than those on modern space telescopes. But as they examined the data more closely, it became clear this wasn't a malfunction. The changes were too consistent, too structured. Something external was at work. So what could it be? One possibility is that Voyager 2 encountered a moving interstellar cloud, patches of plasma drifting through the galaxy. These clouds can be vast, stretching for light years, and they move relative to the sun at hundreds of thousands of kilometers per hour. But here's the strange part. The data didn't fully match what we'd expect from a plasma cloud. The shifts weren't diffuse and broad. Instead, they came in pulses, concentrated like the signature of an object with boundaries. That suggested something more compact, more defined, than a random haze of particles. Another theory is that Voyager may second have detected a rogue object, a body not bound to any star system. Rogue planets are known to exist, ejected during the chaotic formation of star systems and left to wander interstellar space alone. Estimates suggest there may be billions of them drifting silently between stars. But even rogue planets are enormous compared to Voyager 2's instruments, and their detection from such a tiny spacecraft would be almost impossible. What Voyager 2 sensed didn't match the gravitational tug of a planet. Instead, it was more like a presence moving through the plasma, interacting with the magnetic field in a way that hinted at something smaller, yet still massive enough to disturb the local environment. Here's where the mystery deepens. Scientists analyzing the signals noted that the disturbances had a rhythm, almost like a heartbeat. They weren't continuous but appeared in intervals, rising and falling as if whatever caused them was rotating, pulsing, or generating emissions in cycles. Natural phenomena can behave like this. Pulsars, for instance, are rotating neutron stars that send out beams of radiation in pulses. But Voyager 2 isn't anywhere near a known pulsar, and the signal wasn't electromagnetic radiation in the traditional sense. It was a physical interaction with the local medium, something literally moving through the interstellar plasma near the spacecraft. Some have speculated that this could be evidence of an interstellar object, something like Oumuamua, the mysterious elongated body that passed through our solar system in 2017. That object moved in ways that puzzled astronomers, accelerating slightly without a clear explanation. Could Voyager 2 have encountered another such body, not in the inner solar system this time, but out in the deep void where few instruments can see? If so, it raises profound questions. Interstellar objects may not be rare visitors. They may be far more common, drifting between stars, unnoticed until they brush against the tiny sensors of probes like Voyager. The idea becomes even more unsettling when considering what Voyager 2's limited instruments can't tell us. Its cameras were shut down long ago to save power. That means whatever it detected, we will never have an image of. All we have are the indirect signatures left in the plasma measurements, the faint ripples of its passing. Was it a fragment of a comet ejected from a distant star system? A piece of interstellar debris? Or something that doesn't fit neatly into any category we know? If this were simply debris, a random rock or icy shard drifting through space, the story might end here. But Voyager 2's data didn't resemble a passive object merely drifting along. The signals suggested interaction, like a presence actively disturbing the environment around it. Imagine dropping a stone into calm water. The ripples radiate outward in predictable circles. But this was different. It was like watching ripples that seemed to change direction, to pulse with intention, to interact with the plasma medium in a way that implied structure. This is what has puzzled scientists most. In interstellar space, interactions are subtle. Magnetic fields weave like invisible threads, particles drift in thin distributions, and only massive bodies leave noticeable signatures. But Voyager 2 recorded something moving at a velocity and in a manner that seemed neither chaotic nor completely natural. It carried with it a kind of rhythm, a repeated disturbance, as though it wasn't just tumbling randomly but had a pattern of motion. That's what makes this so unusual. One possible explanation is that Voyager may have passed near a magnetic filament, part of the complex web of structures in the interstellar medium. These filaments can stretch for vast distances, carrying charged particles and influencing nearby regions. If a knot or denser region within such a filament passed near Voyager, it could generate the kind of pulse-like disturbances observed. But here's the catch. The direction and speed of the pattern didn't fit neatly with the expected flow of known interstellar magnetic structures. It was as if this anomaly moved independently of the background field, carving its own path. Another hypothesis suggests the anomaly could be tied to dark matter. Dark matter doesn't interact with light, making it invisible to telescopes, but it is thought to make up most of the universe's mass. Normally, dark matter interacts only through gravity, so a probe like Voyager 2 would notice it. But what if, in some regions, dark matter clumps more tightly or interacts faintly with ordinary matter in ways we don't yet understand? Could Voyager 2 have brushed against one of these clumps, triggering unexpected reactions in the surrounding plasma? If so, it might represent the first direct clue of dark matter's hidden structure on a small, detectable scale. There's also the intriguing possibility of exotic astrophysical remnants. Imagine a shard of a dead star, a piece of neutron star crust or exotic matter expelled during a supernova, hardened and wandering through space. Such material would be unimaginably dense and strange, capable of warping local magnetic fields as it drifted. Even a fragment only meters across could exert profound effects on its surroundings, effects that Voyager's sensitive instruments might pick up. The question is, how likely is it for such a fragment to pass so close to a lone spacecraft in the endless expanse? Skeptics argue the simplest explanation could still be instrumental artifacts, quirks of an aging probe operating far beyond its expected lifespan. Yet, the persistence and structure of the anomalies make this harder to accept. Voyager 2's instruments are old, yes, but they are consistent. They don't suddenly invent rhythmic pulses without cause. Moreover, cross-checks with its different sensors confirmed the disturbances. This was not a ghost in the machine. Something real was out there. The most tantalizing possibility, of course, is that what Voyager 2 encountered was not a natural object at all. If an artificial probe from another civilization existed in interstellar space, drifting through the galaxy just as Voyager does, its interactions might appear strange and unexplainable to us. An engineered craft moving with propulsion or emitting controlled pulses could disturb the plasma in patterned ways that mirror what was observed. To us, with our limited tools, it would look like an anomaly, something moving in a manner that doesn't fit our catalog of natural phenomena. We know this idea is extraordinary, and it demands extraordinary evidence. Yet the mere fact that Voyager 2 recorded something so odd invites speculation. After all, humanity itself has already sent two emissaries, Voyager 1 and Voyager 2, into interstellar space. If we have done it, is it impossible to imagine that others, somewhere, might have done the same? Perhaps space between stars is not as empty as we think. Perhaps it contains relics, wanderers, or travelers from civilizations past and present, each silently crossing the galactic ocean. The difficulty is that we may never know. Voyager 2 cannot turn back to take another look. It cannot photograph or chase whatever passed nearby. It can only continue its one-way journey outward, leaving behind a mystery that will echo in scientific discussions for decades. Some argue that as more interstellar probes are launched in the future, missions specifically designed to leave the solar system and study the interstellar medium, we may encounter similar disturbances again, providing a clearer picture. Until then, this singular event remains open to interpretation. And yet, its implications reach far beyond the anomaly itself. If Voyager 2 can detect something moving out there that is not a planet, not a star, and not easily classified, then our assumptions about the emptiness of interstellar space may need to change. Perhaps the galaxy is far more dynamic than we realize, filled with drifting fragments, hidden clouds, or even technological artifacts waiting to be discovered. The encounter may not just be a curiosity, it may be the first whisper of a larger truth about the nature of the space between stars. Voyager 2's discovery forces us to rethink the way we view the vast stretches of space. For decades, we imagined interstellar space as a silent void, a place where almost nothing happens, where only radiation and faint magnetic fields drift without drama. But this event hints that it may not be so empty after all. Space could be filled with structures, objects, and phenomena that we have yet to catalog. Every ripple, every unexplained pattern, is like a message telling us that there is more to learn, that our universe is not fully mapped or understood. If what Voyager 2 encountered was natural, it may have been a phenomenon we've never seen before. Just as earlier explorers on Earth stumbled upon unknown species or new lands, Voyager may have brushed against an interstellar phenomenon that defies our current models. If it was a fragment of a dead star, a clump of exotic plasma, or a rogue shard of matter drifting alone, then studying such encounters could eventually reveal the hidden architecture of our galaxy. It could help us refine our understanding of cosmic evolution, teaching us how stars die, how matter drifts, and how invisible forces shape the void between systems. But if it was something artificial, an interstellar traveler like Voyager itself, then the meaning is even deeper. It would prove we are not the first to send emissaries into the stars. It would suggest that civilizations long gone, or perhaps still thriving far away, have also left their mark on this galactic ocean. A lonely craft, drifting endlessly, might have passed Voyager 2 like two ships crossing in the night, unnoticed except for the faint ripples they left in each other's wake. That possibility alone shifts our place in the cosmos, reminding us that we may not be alone in building machines to reach the stars. The haunting part is that we cannot see it again. Voyager 2 has no cameras to record what passed by, no way to circle back or send higher resolution scans. It only gave us a fragment, a whisper of data that will be debated for years. And maybe that is fitting. The Voyager missions were always about reaching beyond the known, about sending something fragile and human into the deep unknown. Along the way, they have revealed not only the beauty of our solar system but also the mysteries that lie beyond it. This is just one more chapter in that legacy. Decades from now, Voyager 2 will fall silent, its power depleted, its instruments frozen in the dark. But even then, it will continue to drift, carrying with it the golden record, a message from Earth to the stars. Perhaps what it detected out there was just another fragment of that great, unending story of exploration. Perhaps one day, future missions with more advanced instruments will follow its path, armed with better tools to investigate what lies between the stars. For now, Voyager 2 has given us something to ponder. Something moving in interstellar space that is not a planet, not a star, and not what we expected. It is a reminder that the universe is full of surprises, that discovery does not always come in clear images or dramatic events, but sometimes in faint ripples on the edge of understanding. The story of Voyager 2 and its mysterious encounter will continue to echo in science, in imagination, and in our shared curiosity about what lies beyond. Perhaps one day we will learn the truth about what moved out there in the deep, silent dark. Until then, the mystery remains, etched in data sent across billions of miles, carried by a spacecraft that has journeyed farther than any before it. Voyager 2 has shown us once again that the universe still holds secrets waiting to be revealed, and that even in the quietest reaches of space, something may always be moving.